Hello children, welcome to Math Park. Our today's video is on speed time graph. Recently we have done the video on distance time graph. Today we are going to do on speed time graph. So very important, I'm going to take two questions and which are important and similar type of questions do come in IGCSE and checkpoint exam. So do watch till end, and if you are new to the channel, please subscribe. So what are the points that we need to remember here? In speed time graph, the gradient is the acceleration. So acceleration is the velocity per unit time. Acceleration is equal to velocity per unit time. So velocity is the change in speed that you have learned in physics also. So in math here, the acceleration is nothing but the gradient or a slope. And we have learned what is a slope using the formula. Also by using the graph, vertical distance upon horizontal distance. And the area under the graph is the distance traveled. That is, these are the 2 points that you have to remember when we are solving the questions on a speed time graph. So let's take a question. The speed time graph shows the speed of a car over first 50 seconds of a journey. So you can see the speed on y-axis here and the time on x-axis. So we have the parts of a question here. So this is the graph. First question, it says, calculate the acceleration between 0 and 10 seconds. So 0 and 10 seconds, that is between this time, what is the acceleration that we need to calculate. So for that, as we have seen that the acceleration is nothing but the gradient or a slope. We find the vertical distance, which is 25, and the horizontal distance is 10. So the slope is, or acceleration is 25 by 10, which is 2.5 meter per second square. Very important to write the unit. Then let us go for the B part. Calculate the acceleration between 10 and 50 seconds. So between 10 and 50 seconds, from 10 seconds to 50 seconds. So this is the distance that is being traveled. Okay, so we find the slope here. Since the acceleration is asked, the gradient is nothing but the acceleration. So vertical distance here is 5 and the horizontal distance is 40, and 5 by 40, which is 0.125 meter per second square, is the acceleration between 10 and 50 seconds. Got it? The C part of this question, calculate the total distance traveled in first 50 seconds. So the distance traveled is nothing but the area under the graph. So this is the area, the shaded one. So we divide this into the parts so that we know the formula. So we can have one triangle here and one trapezium here. So the area of a triangle is half base into height, and area of a trapezium is half h. The height is this 40. This is the height over here, 10 to 50, which is 40. And the sum of the parallel sides, which is 25 and 30. So on simplifying this, we get it as 2 20s are. So we get 2 1s are, 2 5s are. So we are getting 5 times 25 is 125. And 25 plus 30 is 55. 55 times 2 is 110 and 10. So 1100 plus 125, we get this 1225 meters is the total distance traveled in first 50 seconds. So what we need to remember, that the distance traveled is area under the graph. Okay, let's take another question here. So calculate the average speed over first 50 seconds. Now we know that the speed is distance upon time, and distance we have just calculated, it is 1225 meters. So 1225 divided by 50, we get 24.5 meter per second is the average speed of the vehicle, the car. Okay. Now this is how we have done this D part, average speed. The second question begins here. The speed time graph, it shows the speed of a car over 45 seconds. So this is 0 and this is here 45 seconds. This shows the speed of a car. We are asked to solve here the acceleration between 0 and 20 seconds. So this is where, so we find acceleration is again nothing but the gradient. So vertical distance is 35 and the horizontal distance is 20. So 35 by 20, the acceleration is 1.75 meter per second square. Okay. Then calculate the acceleration between 20 and 45 seconds. So between 20 and 45 seconds. Now acceleration is again a slope. Now what is the slope? When the line is sloping from left to right, it is negative, that we have learned in the video on the slope and graph. Also remember, whenever the velocity decreases, velocity is what is happening, decreasing. So whenever the velocity decreases, the acceleration is negative. The acceleration is negative. Okay, that we need to remember. So this is how the gradient, now we have seen that this is why it is going to be minus 35 by 25. So let us simplify this, 5 5 and 5 7 za. So 7 upon 5, which is 1.4, minus 1.4 meter per second square. It is also called retardation or deceleration. So the acceleration is negative whenever the velocity decreases. We need to remember this. The next part, calculate the total distance traveled by the car. So the total distance is again the area under the graph. It is a simple triangle here now. So we know that the area of a triangle is simply half base into height. So the base here is going to be 45 and the height is going to be 35. So half into 45 into 35. So this is how we get the area of this region as 787.5 meter, and this is nothing but the distance traveled. Now, though it is area under the graph, remember the unit of the distance we are writing here, it is a meter. So it is the distance, that is why we write the unit as meters over here. The next question, it says calculate the average speed over 45 seconds. Now, speed is distance upon time. Distance we have just calculated, which was 787.5 divided by 45. And this is what we get it as 17.5 meter per second is the average speed. So children, if you like the video and if it is helping you, please share with your friends. Thank you for watching. Have a good day.